Okay, so welcome back. So now what we're going to do is we're going to talk about a problem-solving strategy to help determine what the limit of a function is. Okay, so the way we're going to do it, this is basically just not trial and error, but it's more of a input type of process. Okay, so what you're going to do is step one, you're going to start by creating two tables rather. Okay, so you're going to have one column x and f of x, and another table with column x and f of x. But over here, what you're going to do is you're going to subtract smaller and smaller values from your a value, right? So let's say we want to find the limit as x approaches a, okay, some value, right? What you're going to do is you're going to create a table where you're going to put in a minus 0.1, and you're going to find the value of that function and at this value, and then you're going to take a minus 0.01 and find f of x, f of that value, and then you're going to do x minus 0.001, and you're going to continue on as necessary. So 0.0001, then subtract off 0.000001, and so on. And then over here, you're adding smaller and smaller values to a. So you're getting closer and closer and closer to a from the left side. Here you're getting closer and closer to a on the right side. Okay? And so you're going to do the same thing over here. You're going to add 0.1 and find the value of the function there. Then you're going to add 0.01 and find the value of the function there. And so on and so forth, and you're going to go as necessary. That's step one. Now, what you're going to do is then once you have enough values, let's say 4, 5, 6, 7, 8, however many values you need in your table, you want to look at the values of f of x in both tables and see, step 3, if both of those columns are approaching the same value, a common y value. That is going to be the limit. Okay? And we would state that the limit as x approaches a of f of x would be whatever that common y value that we're seeing them both columns approach. Now, step 4 is more of a way of confirming using a graphing calculator. Now, even though I don't use graphing calculators in this class, there's nothing that says you can't use a graphing calculator to check your work and to help your understanding. You just won't be able to use a graphing calculator on the exam. You could use any other calculator, but not a graphing one. But for the purpose of understanding and the purpose of proving things to yourself or the looking at a graph, I'm totally fine with that. Okay? I used graphing calculators in all of my calculus classes when I was taking calculus. Okay? The only thing in this class, I don't allow you to use a graphing calculator on the exam, okay? Because everything you can do on a calculus exam, you can use a regular calculator, okay? In the rare case that, again, you have to use a graphing calculator, I'll let you know. But anyway, but yeah, you could use a graphing calculator. What you would do is you would graph the function in the window that contains whatever your a value is. And then what you would do is you would use the graph and you would verify whether or not it actually approaches that value from steps 1, 2, and 3. Okay? You can also use the tables menu on your graphing calculator too, and you'll bring up a table and you can actually scroll down the table and verify it that way that that the function is approaching whatever particular L value or Y value. Okay? But that's it. That's how you would use this problem-solving strategy. Okay? Have a great day.